I'm going to go ahead and finish recording to get 6.2 covered. So 6.2 moves a little bit more into the algebra. We're going to start solving equations and we're going to solve proportions. And with any sort of time we have a class, whether or not it's online or in person, everybody's math skills come in so diverse that all I can do is give you a lot of the steps. If you are a little bit more behind, feel free to get in touch with me and I will help you catch up on what you need. And if you already know this, I'm sorry that I'm taking up some of your time, but at the same point, at least you can be thankful the work will be easy. So when we have an equation in one variable x, this is a linear equation. Now, it's certainly possible to write linear equations with more than one variable. We can write them with two variables. But right now, we're just dealing with one variable. And it would be something that can be written in the form ax plus b equals 0 whenever you have numbers in front of a, so 3x or something, and b, you're going to have a number there. A can't be 0, b could be 0. Of course, the truth is the variable doesn't have to be x, so we could take this exact same definition and you could replace the x with the y, and it would be a linear equation in the variable y. So really what this means is you're going to have equations now, not just expressions, and our equations will only have one variable letter used, although it could show up in more than one place. And we're going to solve these. So when you solve equations, I just like to use something that you've related to. You've all wrapped gifts before. Even though you might not think that, the letter X is an exciting present, when we solve an equation, it is really just like unwrapping that variable. You can't get a gift out of the box unless you undo whatever was done to wrap it. So if somebody has really gone through the trouble, you have to take off the ribbon or bow and then take off the outside wrapping paper, then open the box, then deal with the tissue paper before you can ever see what you have. Now, if they've only put it in, a Walmart sack, all you've got to do is open the sack. So that's where I have a little note down at the bottom. The number of steps to open your gift is directly related to how they wrapped it. The more wrapping is on it, the more you have to undo. Now, when you get this all done, I know you're going to be so excited because when you finally get your box entirely open, be like, ooh, just what I always wanted, X. I have X. But you could pretend. Really, in our last little session, we were just talking about Pemdas and order of operations. So you can think of what if you were plugging in a number, what would you have to do to that variable? So what does this equation do to the variable? And then you've got to undo it. So I've got my Pemdas kind of turned over and backwards here because you have to really reverse this. Instead of undoing parentheses first, you have to undo them last. So I have a thing here, if we're going to evaluate, we're going to use Pemdas, but when we solve, you could think of it as SADMAP, although you won't find that written in a math book anywhere. But you have to undo any addition or subtraction, and then undo any division and multiplication, then get rid of your exponents and things. So sometimes if your equations, as far as parentheses go, if your equations are really complicated, you could simplify some first and then solve. And that's typically what we do if there are parentheses involved, although that's kind of an option. So if we solve a linear equation, these are the steps. So if you are using a smartphone or something and you wanted to take a snap of the steps involved, there you go. We're going to simplify each side of the equation, or each side of the equal sign, by going ahead and clearing out those parentheses so that we're not trying to deal with that. Go ahead and combine any like terms so that you only have to undo the one thing. So it's kind of like, if they've wrapped things in several boxes, we're going to get it all together into one box. Then we collect the variable on one side of the equals. It could be on the left, it could be on the right. I typically will do it to the left unless I can avoid a negative number that way, but it doesn't matter. Isolate the variable has to do with when you multiply or divide a lot of times, or add or subtract, to get that variable to be the only thing on the equals, so that it simply ends up saying X equals. And then why not go ahead and check it? There are some types of equations in algebra that require a check, because even if you've done all the math correctly, you could get a wrong answer. That's called an extraneous solution. Now, that's not the case in today's work, But why not get into that habit of just going ahead and checking it, particularly if you've got a calculator, it's not too hard to do. So this is what your homework choices often look like. So before I do an example, I just kind of wanted to say, when you find a solution like x equals 3, then you would normally write that solution in braces. Now, just to remind you of what braces are, they're the ones, I won't be able to do this beautifully, but they're the ones that have that little squiggle. So if you find out that x equals 3, then you would put a 3 right there in parentheses. But you could end up with all real numbers or the empty set. So when you're doing your homework, they're going to give you a problem. And then the very first choice you're going to get is usually what I have here. It's a little bit fuzzy because I copied it and pasted it from a homework question. So you will either choose A, B, or C. The solution set is. And you're going to do that when you know the number that x equals, or you know the number that y equals. However, when you are solving equations, sometimes you don't get a simple answer like that. So that's what B and C are about. So that's why I have a little note here about let's talk about when B and C happen. If you are solving an equation, and I'm just going to kind of put a note out here, if your variables disappear, and I'm going to put quotations around that because it's not like it was a magic trick. I know what happens to cause this. But if you are suddenly solving an equation, all of your variables disappear, then you have two options left. One of them is B. And I'm looking at this B and C. They're right here. And the other one is C. If B happens, then what is left is true. That sounds funny, but an example could be, what if you were solving your equation and all your variables disappear and you're left with something like 3 equals 3? That's kind of a, well, duh, I knew 3 equals 3. Then that's a true statement, and that's when you're going to choose all real numbers, because as long as x is a real number, I mean, you can't pick the wrong x for, no matter what x is, 3 equals 3. On the other hand, if your variables disappear and what is left is a lie, like maybe what if it says 2 equals 3? It does not equal 3. If you are left with something that is impossible, then there's no possible x you could choose that would make 2 equal 3. That does not happen. So if that's the case, then that's when your answer is the empty set, and it means that there is no solution. So if you're left with if the variables go away and you're left with a true statement, there are infinitely many solutions, and you need to choose option B. X is a real number. It means any real number works. If you are working a problem and your letters go away, if you're left with something that is impossible for it to be true, then choose the empty set. There is absolutely not a single X that makes this work. So now let me solve those equations. And again, I'm going to pull back up the whiteboard I have. Yeah, there it was. Let me get back to it, because I can just write on it a little bit easier. So we'll work some of these problems, okay? So if you were going through the process, and I know some of you can probably work some of these in your head, but we'll pretend that you can't. You would say, well, what has happened to x here? This 5 is multiplied to x. So if they've multiplied, you need to undo multiplication, which is division. So you would divide on both sides. So those 5s just cancel. And we have x equals, and negative 25 divided by 5 is negative 5. Oh, a terrible box. Okay, and yet it knew. So now I would check that answer and just make sure it works over here. 5 times negative 5 is negative 25. Check. That one clears. Okay. Negative 6x equals 3. They've multiplied x by negative 6, so I need to divide by negative 6. So x equals, now here, 3 over negative 6, I could use a decimal because it is nice and stops. It's negative 0.5, or I could just reduce it and say negative 1/2. Okay, so those are those two. Now, if I go to this next problem, it's actually a two-step problem. I can't do it in the one step. Let me go ahead and finish this weird box because it'll drive me crazy even if you don't care. So here I have 3x plus 8 equals 50. So now opposite of the order of operations, I need to undo any addition or subtraction first. Remember I said sad milk? Get a drink of water here. It's also visually speaking, you can just think of it as this 3 is really close to that x, so it's hanging on tight. It's harder to pull off, so do it last. That's not math terminology, but it may help you remember which one to do first. So when we say subtract 8 from both sides, remember that's both sides of the equal. So you're going to put one of them right under the 8. Those cancel. But your other one, I commonly see students put it over on the same side of the equals, but that won't work. You have to do the other side. So 50, it's like we're wanting to unadd 8. So to unadd 8, we are subtracting it. So then we end up with 3x equals 42. If 3x equals 42, then I want to divide both sides by 3. And x is equal to 14. So again, that means 14 times 3. Well, 14 times 3 is 42, and 42 plus 8 is 50. So here, 5x minus 4, parentheses, x plus 9, close parentheses, equals 2x minus 3. So this is one that initially you want to simplify each side first. There's nothing on the right-hand side, 2x minus 3. You can't simplify that. They're not like terms. But here on the left, I'm going to take this negative 4, and I'm going to distribute it through the parentheses by multiplication. So I get 5x, negative 4 times x is negative 4x. Negative 4 times 9 is negative 36. And then it still equals 2x minus 3. Now, combine your like terms. So 5x minus 4x is 1x, so I don't really have to write the 1. So x minus 36 equals 2x minus 3. Now you're at the point that the instructions, when it had the steps down, said collect the variable. So that means we want to get the variable on one side of that equals. So I can either subtract x from both sides, or I can subtract 2x. I'm choosing to subtract x so that I don't have a negative value. Not that I wouldn't get the right answer anyway, but I find that almost all of us make more mistakes with negatives. So my x's now have gone away on the left. So negative 36 equals 2x minus x is 1x minus 3. And now the only thing with my x's is minus 3. So if I'm going to undo that, I add 3. So really, see, we did a lot more simplify here than we did of the actual solve process. Simplifying helps make that process shorter, actually, even though this is taking up several steps. So this one is negative 33. Oh, can't draw a box for nothing. Not when I'm looking at a black blank, something with no lines on it. Skill I don't have. All right, so we've solved that one. So now we have one more fairly lengthy one over here. If it says 5 parentheses 2x minus 8 minus 2 equals 5 parentheses x minus 3, and then plus 3 at least on the plus 3. So on the left-hand side, I want to distribute that 5 into the parentheses. And then on the right-hand side, I want to distribute into the parentheses. So we're going to, again, simplify first. So I end up with 10x minus 40, I still have a minus 2, equals 5x minus 15, and I still have a plus 3 sitting there. So again, still simplifying. On each side, I can combine like terms. So 10x minus 42, because those are both negative, equals 5x minus 12. Now is when I'm really ready to start that solve process. So I want to collect the variable. I can either subtract 10x from both sides, or I can subtract 5x. And again, you'll get the same answer either way, but I'm going to subtract 5x just to avoid getting a negative. So 10x minus 5x is 5x. I still have minus 42 equals negative 12. Don't forget when you're doing this sort of work to watch in front of your numbers you bring down. Is there a negative? That's a common mistake for people. Forget to copy that negative over. Now I'm going to add 42 to both sides of the equals. So 5x equals 30. And now that 5x equals 30, I only have that one last step. So I want to, it's been multiplied by 5, I divide by 5. So x equals 6. So in every single one of these we've done, we have gotten a single clear answer. And on the homework, you would end up choosing option A. And then in the box that has the braces, you would write 6. Okay, in this case, you just want to write that answer. So here we're just getting a simple answer. You're not going to type in x equals 6. If you type in x equals 6, you get it wrong. Option A, the solution set is, and you write your answer just inside there. So that's what I mean on that. So now let's look at this, cross products. Cross products is a cross products principle for proportions. Proportions to you are going to look like fractions, but the difference is we don't think of them as being a part of a whole. Like if you have the fraction 3/5, you mean you have 3 parts out of 5 parts of the whole thing. So a fraction is parts of a whole, but when we have proportions, we can write them like fractions so they can look like it, but they're actually individual numbers that represent different things. So you might have a fraction of online students compared to all students, or you might have a fraction of in-room students compared to online students. So they can both represent students, but they don't represent the same thing. They can also represent very different things. So you could have the number of computers to the number of students. So those are not the same, but we can still write it like a fraction. So that's the difference. Proportions are 2 different numbers that we're looking at by comparison, whereas fractions are actually parts of a whole. But when you have proportions that are equal, then their cross products are equal. So here, if you write these 2 things, and if you cross multiply bottom to top or top to bottom, you get the same thing. So we use that principle when we are solving problems with proportions. We do cross multiplication, and that gives us an equation that we solve by the same methods we just did. So here's a couple of them for us to look at, and they're short enough I think I can do them on this particular screen. So here what you want to do is cross products. I can do 10 times 3 equals x times 2. However, nobody writes x2, so I'm going to go ahead and write 2x. As long as you are doing a cross product, it doesn't really matter if it's bottom to top or top to bottom. So you just want to multiply on the cross. So 10 times 3 is 30. So 30 equals 2x, and then divide both sides by 2. And x is 15. Okay. Here we have an expression. So when I do this on this last example, when I do this, I want to use parentheses as I'm doing my cross product. I'm going to do this other one first, 22x. So this time I went top to bottom. And then 2 times that parentheses. And I could put the 2 behind the parentheses. It makes no difference if you go top to bottom or bottom to top on this. So this is how we set up our equation using our cross products. Then we use our same principles we've done before. So that means I'm going to simplify first. And 2 times 60 is 120. 2 times negative x is negative 2x. Now here I could subtract 22x from both sides, but that would leave me nothing on the left. So I definitely am going to choose to add 2x to both sides. As long as you get them on the same side, it technically doesn't matter, but it can give you some results you like better along the way. So now I have 24x equals 120. Divide both sides by 24. And x equals 5. Suppose it said 4 parentheses, x plus 2 plus 1 equals 7x minus 3, open parentheses, x minus 2. Okay, so this will be our last one. I just kind of want to show you what I meant earlier. So I'm going to distribute on both sides of my equals first. I've got a 4 to distribute. And then I've got this negative 3 to distribute. So that gives me 4x plus 8 plus 1 equals 7x. And then negative 3 times each part of that. So negative 3x plus 6. Now I want to go ahead and combine my like terms on each side. So over here on the left, I have the 8 plus 1. So that's 4x plus 9. On the right-hand side of that equals, I have 7x minus 3x. So that's 4x plus 6. And some of you can see what's happening already, but if you didn't, no big deal. You think, okay, the next step is collect the variable. So if I subtract 4x from both sides of this equation, this is what I meant when what if a variable disappears? This now says 9 equals 6. That is a lie. Remember on the slide where I said if it lies to you? Okay, and I think that was slide 16, so I'm going to click back. If it lies to you, like you get 2 equals 3 or 4 equals 6, then you should choose option C. The set is no solution. So here what I would choose is no solution, and no solution is the answer. And if you're working your homework and it asks you what kind of answer it's going to be, you're going to choose option C, no solution. Okay? If on the other hand, I'm not going to work another problem, but if on the other hand you did the same sort of work and you came out with 6 equals 6, then it would be all real numbers because that is true no matter what. Okay, so I'm going to go ahead and in this video log off. And you guys, don't forget there's a discussion questions. I know they can drive you crazy, but they're important as far as getting your grade up as high as you can. And they satisfy, you know, our requirements as far as this course goes. Send me an email or send me really the Ask the Instructor link if you get stuck on some sort of homework, and I'm happy to help you. You're halfway through the course. Don't quit now.